Hey, hello everyone. So my name is Philip Pinto. I'm the creator of Tuga Tech Talks. I hope these kind of insights and best practices help you guys to succeed in your geospatial projects. And today we have Paul Jacob. It's my first guest, and no one better to speak about best practices for topographic survey preparation, especially with LiDAR technology. So, Paul, glad to have you here. Let us know a little bit more about you.
Well, thank you for having me, Philippe. It's a pleasure to be on Tuga Talks. My background, I'm a civil engineer by trade. Been in the business for about 37 years. Been around LiDAR for about 25 years. And in that time, I've spent quite a bit of effort in just trying to find the best practices using geospatial technologies to help with infrastructure survey and infrastructure design. So I've had the pleasure really to work with some of the greatest technologies in the world when it comes to this kind of this space. And I'm happy to share some of those experiences with your audience.
Great, and that was basically my main thought when I was preparing this session. And I said, well, I need to bring Paul in because he is my guy to help me with this. So, well, let's get this started. And well, basically, I've just shared some best practices and insights that I have from previous experiences. But I really wanted to hear from you. And well, I guess that the first thing that everyone should do is get a great overview of the project. So
Of
um,
course.
I'd like to ask you when it comes to LiDAR projects, if you get a request of a certain area, how would you study this area? How would you plan not only the field work, but also the office, but also use this planning to study for your proposal to make sure that you are competitive and, of course, you are giving the best price using LiDAR technology.
Yeah, it's a great question. So typically, somebody might come to a practitioner like myself and ask them for a survey. Typically, they know that we are a geospatial firm, so they know we have equipment. They may not know exactly what's the best tool for that particular job. So I would request to have a conference call with the client or prospective client to look at the site if we can. It's great if it's close enough and you can go see it. You might
Mhm.
physically go to visit the site, but a lot of times you might just have to use Google Earth and Google Street View to take a look around and see what the facility looks like. Uh, that's great when it's a highway or some type of a site, but maybe not very easy with the railroad. But one of the things we like to do is just try to figure out which type of sensor is going to provide the best results. So you're thinking about
Yeah.
things like line of sight. You're thinking about whether or not you have, is the facility, is it a good facility for a road mobile lidar type collection? Maybe it's a real wide site and it might need a combination of mobile and drone or
Sure.
UAV type
Exactly.
system. So you're trying to figure out what the best equipment to get the job done efficiently and provide a great product. Because what you really want to get is complete coverage with the lidar sensors and the imagery,
That makes sense.
and not leave yourself guessing. Because you've got gaps in the data. So typically, we're gonna take a look and try to determine the right equipment, the right sensor. That would be the first step in the process, and then we move to scoping the project after that.
And the better you do this, I believe the better will be your proposal,
Yes,
and also you will start seeing any kind of constraint you might have in the field, right? So,
that's
well,
correct.
if you were to hire, if I were to hire you for a project, let's put it in this way, how would you prepare to carry out this work? So tell us, um, would you would organize your teams in a specific way, how would you do this, and how would you select the best data collection, check if everything is working properly, but also in terms of specific and very important aspects like to prepare this field work for the maximum uh, technical and the financial efficiency. So you don't want to incur in extra costs, especially non-expected ones, but also
Yeah.
for the safety of your crew. So how would you go in more detail to do that?
Yeah, so there's a lot to unpack there. So for me, the first thing I want to establish is a really good scope that we agree to and the client agreed to at the same time. And I recorded a video for you, and I
Oh,
don't know
let me bring it
if you
on.
can
Yeah,
pull that up.
let me
Yeah,
bring it
because I
on.
think what happens is the customer will deliver for us typically a KMZ that has a single line that might show the limits from beginning to end for the project. And that's great. That's helpful. That kind of gives us a general idea. But what I typically do is I go in then and use Topo Mission, which is a tool, a free tool from Topodot that really allows you to kind of lay out the mission plan for both your drive lines and your control, and that is something that the entire team can benefit from because we know exactly how much work's involved. So the video now shows where I've actually gone to the same location, which is, by the way, near our offices in Florida. And I'm going to go in and start creating trajectory nodes. And I'm going to name the trajectory one. And I'm going to get started by just drawing the, let's call it the eastbound side of the roadways. I know I have to make two passes on this road. I'm going to skip ahead. And now we're kind of wrapping up at the east end of the project, and I'm going to set the speed to 35. And this, what this does is help us understand how long it takes to actually collect the data. So once you do that, the time being calculated by Topo Mission is much more effective and kind of gives you a feel for how long it might take for that pass. The next thing I'm going to do is start the second trajectory. So we'll just call that trajectory two. And I'm going to basically work my way westbound and just kind of working my way down the line. Same thing here. I'm going to skip ahead to the end, and then we can actually show how we finish that up, change the speed to 35 miles an hour. And now that two trajectory main line part of the project has been set. In conversations with the client, we realized we also have to pick up some of the ramps at the east end. So I'm going to go ahead again and create these trajectories that really are just setting the limits of where I want to drive, and really extremely helpful for the field team to know the limits of where they're going to start and stop their collections. Again, set the speed, and I'll skip ahead now, and you'll see that we kind of go in. We got all three ramps in there, and the interchange is kind of completed,
Hmm.
so you get a general idea of how that would work. Okay, so now I've got basically five trajectories. I've got, let's see, about 8.5 miles of driving to do, and I'm going to do all those drives at about 35 miles an hour. So I got a pretty good feel for it's going to take about 14 or 15 minutes to actually do the driving, right?
Okay,
The
okay.
other thing I'm deciding to do is on the main line of the project, I might make two passes. And the reason why I would do that is because sometimes there's vehicles in the way, and they might create shadows in my lidar data. So by doing two passes, I'm increasing the amount of mileage or kilometers driven, but I'm actually making sure I've got full coverage of the data in a
You don't
on a
you,
busy urban
is
area.
you don't need to go back to the field again.
That's correct. That's correct. Yeah. Next thing I'm doing is actually laying in the cost for control. And now I'm going to decide the distance for the number of control points and the time it takes to actually lay out that control. Okay. So this is going to also help me with my estimating. So I'm going to save off those parameters, and then I'm going to actually start laying down control points. And the way we've decided to do this is say about 1,000 feet or 300 meters or so between the points. You can name your points or give them a prefix.
Yeah.
We'll put MT for mobile target, but that's entirely up to the user to decide how you want to do that. And then I'm just going to start laying out these control points from uh, east to west. And you'll see I typically prefer to do a pair of targets, like one on each side of the road. And then this blue circle that you see in the video is kind of telling me where that 1,000 foot distance is. So where should the next set of control points go is, just beyond the radius of that circle. And it really helps the technician laying out this to put the right distance between your control points. And for those that are unaware, in most of the mobile LiDAR packages, the software packages that come from the manufacturers, there's a recommended distance if you're looking for a certain level of survey quality. And 1,000 feet or 300 meters is probably fairly common for a design grade survey. So now we're just kind of scanning back. And again, one of the things I like to show is you want to try to put these targets where they're easy to see from the vehicle, but and at the same time, not a dangerous place for someone to actually measure them.
And
So I'm
that's the
looking for,
safety. Yeah.
that's right. Safety in mind. You want to try to keep the guys out of the roadway area. And if you can put them on the shoulder or on the sidewalk, that's a great spot to do it. The last thing I'm going to do is save off this project. TPM is the topo emission file, but we can also save it off as a KML. So I'm going to save that as a KML or KMZ, and then I'll open that up and we can actually compare it to what was given to us by the customer. So we had the big dark red line that was given to us by the customer, the potential client. And then we've got our detailed, what I call mission plan, laid out with control. And I'll turn off the first one so you can see the detail. So we
Yeah.
know exactly where we're going to drive, and we know exactly where we want to put our control points. This now becomes something I can give back to the customer, make sure that we're all in agreement, and then that becomes the planning tool for my team moving into the field.
And I think this also gives a very good sense. Well, let me just bring you on. Well, in fact, bring us on to the main page. And that
Mhm.
gives a very good sense for the customer to understand why it's picking your company or any other, because this also shows the level of expertise and control you have in your survey projects, right? So this
Very true.
starts also to provide value to the customer in when it comes to selecting the right service provider, right?
That's correct. Yeah, I think it really does show that there's experience here. We understand the pitfalls, and we want to make sure that we're providing a quality project. So having that scope, visual scope, and that by the way, that KML is something that we would provide with our the tender or the proposal. We would include that with a PDF document. We would say this is the corresponding map of the limits and the mission plan, so everyone is aware what we're planning to do.
And that's show a great professionalism. So, uh, well, and let me address one of your points, because part of this planning is not only to ensure safety, but to make sure that you don't have I don't know, any unforeseen events like a crowded area where it will
Mm.
force you to go back multiple times to the field. So this will also affect the efficiency of the project. And let me ask you this question specifically for field work. Can you share, for example, any experience, or how would you solve a kind of tricky or I don't know, tough situation when it comes to this kind of aspects, so this kind of
Yeah,
constraints that might happen in the collection part of the job?
yeah. Yeah, I mean, one of the things we've noticed, working in the United States and spending quite a bit of time around New York City, traffic volume can be a huge impact. And sometimes Google Earth and Google Street View won't really show you what's truly going on out there.
Yeah,
We've had situations where we thought we could go out there and collect from, on a busy road that maybe have a lot of mileage, a lot of many kilometers, that we can go from 9 a.m. to 4 p.m. and collect the entire day. Then we find out that during the rush hour, the peak volume hours, you can't even move, right?
yeah,
So what do you do? Well, now we're going to move our operations to maybe 10:30 in the morning to maybe 2:30 or 3 o'clock in the afternoon, and that changes the amount of time we're going to spend in the field. The one thing you don't want to do is sit out there in traffic, and not collect data, just collect cars, right? So you have
exactly.
to be able to adapt. The team's in correspondence and saying, hey, we see a lot of traffic. You might even see this during the control aspect. You're putting down targets and you're seeing a tremendous amount of volume, and then we have to adjust and make sure that we're collecting the data at the right time, so that, like you said, the last thing I want to do is give a point cloud to the extraction team that's full of cars and just, the data has a tendency to get, either bunched together or spread out. You really want to smooth, try to stay the same speed as you drive through the site, and collect the data in a nice contiguous way. So that's another thing you just have to be careful of. Another example I'll give you is when you're collecting data on a railroad. Typically we love to work during the daytime because most of these mobile mapping systems have really good camera systems,
Exactly.
and it's nice to have the photo as part of your geospatial data set. But I can tell you, after working on many railroads, they have a lot of restrictions during the daytime. It's very difficult to be out there working on the railroad while they're operating. So we would typically try to go to non-revenue hours. So that might be 11 o'clock at night till 4 in the morning. You have free reign on
Yeah,
the railroad. The one thing you have to sacrifice are the
it's
images,
the
right?
images.
Um, so it's one of those things where, and I would try to discuss that with the client and say, if it's okay with you, it's going to be easier for us to operate at night. We'll be out of your way. The sacrifices, the imagery won't be there. So these are the things you have to think about. Sometimes it's happening in real time. Sometimes you can anticipate it. And I think the key is that you're communicating it with both your own field team and also with the client. So you're setting expectations accordingly.
Exactly. And well, I guess this will also help the office team to get cleaner and better data, especially when it comes
Absolutely.
like situations you said, like crowded areas, etc. So
Hmm.
let's focus now in those kind of activities. So post processing, feature extraction, 3D modeling,
Yeah.
etc. So how would you advise someone as a manager to prepare their team with the right processes, with the perfect knowledge to carry out
Hmm.
these tasks on a project?
Yeah. So most of the organizations I worked for, we saw this entire operation really as two parts. There's the field operation and that kind of, I would call pre-processing, and then there's the production side or extraction. So for us, the field operation team was responsible for, and again, I'll just specifically speak to mobile lidar. Um, it could be the same thought process could be applied to other types of collection. But assuming you're in a mobile lidar environment, uh, the collection team will be responsible for targeting. They would be responsible for driving the site, and then they would be responsible for that pre-processing of the data to some standard LAS type format or E57 format that's in the right place. And they would have to work directly with the surveyor. So sometimes the surveyor is a third party. Sometimes the surveyor might be part of your team. But in either case, we're going to wait for that uh, coordinate information to come in on those control targets. You saw the little yellow
Yeah.
triangles in my topo mission file. That data would be shared with the surveyor. The surveyor would go measure those points for us and then provide us with the coordinate values on those control points. That then goes back to the back to the field team, and they apply control to their data collection and move the data really to the right place in the world. Once they're done, that would kind of be the end of their process. They would deliver it over to the I would call it the geospatial administrator, and
Hmm.
then the geospatial administrator is responsible for really maybe double checking to make sure the data is correct in the right place. And then they're going to take those longer strips of data and tile them into what I like to call consumable pieces of data. So they're going to use, in our case, we always used the Topodot tools to actually take the data, check it against control, make sure that there's no anomalies, look for separation. We want to make sure that there's very little separation between the eastbound and westbound pass, and then we're going to go back, tile the data, and get it ready. In my world, we had TopoShare, and TopoShare allowed us to host that data on whatever the cloud service of your choice. We were Amazon customers, but it could be Azure, it could be anything like that. And then the data is served up in TopoShare as a resource to the people that are actually doing extraction. So the administrator's job is really to make sure the data is right, tile it up, and then serve it via cloud, TopoShare in the cloud. And then the users are actually able to see where the data is and what they're supposed to be working on. Now, when it came to extraction, Philippe, one of the things I like to do was, in order to create the quickest and most efficient deliverable, we would break up the extraction exercises into specific teams. And in a roadway scenario, similar to what we looked at there in Topo Mission, we might put someone in charge of the pavement markings, right? Striping pavement markings. There might be another part of the team that's responsible for brake lines, looking at curb hops and median barriers and physical elements that kind of define terrain. And then we might have a third team that's doing the rest of the features, assets, poles, signs, trees, other elements of the topography. So that way we'd have three kind of parallel processes going on at once. That was a very effective way to get the project moving. And then as a team, we would have kind of check-in meetings.
Hmm.
So those meetings start very early on in that, kind of we what I'll call post-award. We've won the project. Now we have to go plan to go do it. And then we'd have some meetings along the way after the collection was done. We'd have a pre extraction meeting, and then maybe critical states along the way, 30, 60, 90 on a very big project. It kind of depends. If it's a small job, you may just have a beginning and an end kind
Yeah,
of, make sure you always want to make sure you've met the scope, right? Everything's there. Before we give it to the customer, we want to make sure we've
everything
met
is
all
right.
the
Yeah.
requirements. Yeah, everything's right and we've met the requirements. We haven't missed anything. So those meetings are helpful just to make sure that we're on schedule and we're delivering everything that we promised.
Great. And well, part of this job or these activities requires a very good communication and collaboration.
Yeah,
So, can you share with us like what kind of procedure or how would you interact and inform not only different team members now with post-COVID, we have a lot of people working remotely, so
yeah,
that collaboration and communication is very important, but also to inform the client about the ongoing activities, what's the current status of the project. Well, basically to maintain this kind of good relationship, internal and external, and to give an overview of the state of the project, so you can ensure
yeah.
smooth communications.
Yeah, so kind of similar to my previous answer, we would have these check-in meetings right during the process.
Yeah,
I would typically, as a director of the team, I would typically work with what I would call task leads. So there's a task lead for mobile collection, there's a task lead for survey, there's a task lead for geospatial administration, and there might be a task lead for production or extraction. Those four people would probably be meeting with me on a regular basis on a very large project, probably biweekly. If it's a small project, we might do it weekly over maybe a 3 or 4 week period. But the idea is to check in and make sure everyone has what they need on schedule. And I can tell you the most common thing is like the collection team is waiting on the surveyors to provide control, right? So
yeah,
that's the first thing we're waiting for. And as soon as they have that, we're going to sit down and we're going to look at it together, make sure you have everything you need. Okay, good. Then let that second phase of the operation get started. So those types of meetings were very common. And again, the spacing or the timing of them depended on the size and the scope, right? So the
makes
second
sense.
thing that you mentioned is how do you communicate with the customer? So one of the things I like to do is, typically the client, and we worked for larger engineering outfits or DOT or rail authorities. They were your typical clients. I always felt like there was something that they were trying to get done. There was a critical path
Makes
for them.
sense.
In a case of like roadways, it might be they just need to see the curb, and striping. Like as soon as you have that, they need to go. They're going to get started on the process. If they're doing a widening project, they need to see the edges of pavement. Right, that's the most critical element. Sometimes in the railroad world,
The
it might
tracks.
be the center line of the track. Right, they
Yeah,
just need to know where the tracks are. Once they have the track information, we do that track extraction into Topodot. We're able to deliver a kind of preliminary engineering deliverable that gives them something to start with, right? And it may be a portion of the project, like this is the beginning phase, like they have to work on a certain area. But a lot of times it was just an early deliverable could help move that process along for them. The other thing I'd like to do, if we had the ability to do it, in cases where you have a topo share environment that your geospatial team's working with, you can use what they call a JSON file. It's almost the extraction process is happening in MicroStation and Topodot. We're saving out a JSON file, which is basically a web viewable vector file. And it basically lays on top of a Google Map, and you can see the progress, right? That's another very effective way, especially in those kind of key checkpoint meetings, is let's take a look at the progress. You can see, hey, we just have stripes done, or hey, we have stripes and curbing done.
Yeah,
We're still waiting on the other assets. But that visual, you could publish those visuals really the day before the meeting, and super helpful for people to visually see the progress. And I think that goes a long way. I can tell you 45-minute meetings were reduced to 15 minutes because everyone's visually seeing what we're talking about. No one's saying, have you gotten to road X or road Y? We could actually look at that on the map, and it created a very efficient meeting. And everyone's understanding where we are and moving on to the next step in the process.
exactly. And you show to the customer that you have the project in control, and you show
Absolutely.
that you are doing what was required in time. So that's the most valuable thing for customers. Well, Paul,
Yes.
I think all these insights are very valuable. I don't want to steal more of your time, but I'm glad that you have to have you here, and hopefully along these two Tech Talks, because we will have a lot of topics to cover. Uh, Hopefully, I can have you to share some more experiences. But thank you very much to help
It was my
with
pleasure.
us, to contribute to these
Sure.
geospatial insights. And stay tuned for more uh, posts and for more geospatial best practices. Thank you, Paul. See you again.
Great. Thank you.